Hello and welcome everyone to LabVIEW exercises. Today we have another exercise in here in which we will see about some data logging of the time consumed by any appliances in here that I have shown in here, such that if we have some light or a fan or a socket which consumes the electricity and we want to find out after how much time it goes turned off or the power changes, and it should save our time history basically. So in this exercise we will see the use of event structures as well as the use of elapsed time basically. So if I run my program right now, I can show you it's working. So if I turn on the light, you can see the light was turned on this time, and when as soon as I turn off this light, it will show me that how much time it just turned on. And then if I turn on the fan, it will show me the speed as well as at this time it turned on. The 00 will show us that it is the turning on time, and if I change the speed, it will also detect how much for how long it worked, it like turned on the speed of 6. And at this time it turned on to it just changed to speed 5. Like for the 11 seconds it worked on 6 energy meter or like the speed, and then after that it just turned to 5. And now if I just turned it to 4, then it will show me that for 27 seconds it worked on 5 speed 5, and then at this time after 27 seconds it turned to 4. And similarly, if I just turn it off, it will just save it at the energy at the speed level 4. It just turned off at this time. And so that's how we can just see at the power level 4, the socket level was power 4 and it just plug in or turned on. And as soon as I change this, I can see at after 10 seconds it just turned to 3. And so after like stopping this complete simulation, we get a complete set of data in which we will see the light data and the fan data and the socket data as well. So now we will see how we can make this program by going on to our front panel and then placing some um, controls in here, such as this boolean, and change its size. And let's just say this is the light or whatsoever the bulb, and then changing its properties to show boolean text as on and off. And then just let's say we can say it turning on, it will be showing us the red color, so like this way, right? And then we can show the fan or AC or whatsoever by using this toggle switch button and changing its name to fan. And we can also make it go to its properties and show it's turning on and off. And by pressing the shift, we can just drag its on off condition to right side so that it will be properly appear on the right side. And we can also show its control as speed, so let's just place that in here. And to make it look a singular entity, we can use decorations to place that beneath of it, or you can say behind that. So I'll just click on it and let's just go to move to back, so that it will be showing me like a single entity in here. And after that I'll go to silver, and there I'll place a numeric control as a socket, so that it will be showing me like a singular socket in at which different things are just plugged, and we can change its power or units whatsoever. So I'm just keeping it very simple. You can do it at your way. So we just need to see how it works, how the event structure works, and how the elapsed time function is working by doing this simple exercise. So also I will go to silver, and there I will find out the table. And let's just say the first one is light, and then the second one is just sorry, and then place it in here. The second one will be the fan obviously, and the last one will be the socket. Alright, so here are the three tables. We can make them even by going here and making their sizes or making their space equal. And now we will just go back to our program or the block diagram, and there we will start off by placing a while loop here, and then inside of the while loop we will go to event structures and place an event structure in here, and there we will just change it to control and place it inside of this event structure, and there we will go edit events handled by this case, and I will just select the light. So it means that this event structure will be triggered when this light button will be pressed when it is turned on or off. So now I will go to this timing functions, and there I will find out the elapsed time. So I'll set it to elapsed time second, then automatically reset after time triggered. Okay, and this one is quite a bigger one, so I can just use a view as icon, so its size is now like shortened or it shrinks to smaller size. So now I can connect it with the reset, so it means that after time when the light is just set to when we want it turn off, it will be reset. After that I can use a build array function to just combine two things from it. So I will be just needing the present text as well as the elapsed time function. So now I want to keep it or like I want to show it within my table, so I can change it to indicator. If I just connect it right now with this table, I can only get the last value it will be showing, but I want it all the back history, that after how many times it turn on off or like something. So I will just connect it with my outer loop and replace with the shift register, create a constant so that it will be showing that this one starts from an empty string. But here I will not again connect it with this. I will delete this let's just say the wire, and then again I need to place build array function, which will be giving me complete history. And when I connect it, it is still broken because it is showing that you are connecting a 2D string output with just a single or 1D array shift register. So if I just change the index from here, now the error is just removed. So I will make the input in here and just connect that in here, but still the error is here because we have not connected with this loop condition. And so I will create a loop condition as create a control and go to on my front panel. Let's just replace it with something more modern or something like silver, and there I will find out this stop button. So I can just drag it in here to make it more visible, remove it, and now it will won't work because we just also have to assign within the loop, we also have to assign this event structure, because unless it will not get if the stop button is just pressed or not. So edit event handled by this case. um, I just have to do add an event, and there I can just press stop, not add an as an event. I have to add event case basically. So I'll add event case as stop. I'll make it separately. So now this program will be stop, but I want to like keep the values in the iteration, so I'll pass the values within this event case. So now let's just see if it works or not. So now I run my program. If I turn on, it will just show me the time at which it is just turned on, and again if I turn off, it will show me the time for how much long it just turn on. So I can just stop my programming here and show you the complete history or the complete length. Let me just adjust it. So yes, that's how it is. So this is the date and this is the time and for how long it is just turned on. And now it is very just simple to make a copy of this. So like we'll do it in no time. We can make a copy here. We have to just make a few changes in here to make it for the fan. First of all, delete this out, and then also for the light to delete this table as well. So here we can just change it to indicator and then connect that in here, as well as go to stop function and just delete this second button because we do not need as many buttons. And here we can create local variable and then change it to read and then connect it, but still it will give an error. As you can see, the boolean stop function latch function is not compatible with these local variables. So we will close, go to its mechanical action, there will change it to switch when pressed. So now the error is just removed. Go back again, and now here we need the reset element here to be controlled when make it not function. Connect that in here and the input as reset. Here one more thing should be added as the speed function we need to add. So we will be converting like the speed function from numeric to decimal string. As you can see, there is a collision dot which we can remove by just changing it to by changing its representation from double precision number to integer 32. As you can see, the collision dot is just removed. So just only not because of fan, we also need to set these events handled by this case as add an event right now here and set its speed as well, so that when I just press either of fan or speed, this event structure will be triggered. So now if I just go back and run my program and turn it on, and now if I just turn the speed, change the speed, it will also change at like after this much seconds the power change or the speed change to 3, and after this many seconds the power change from 3 to 4, and at that time it is just turned off. So now just go back again. Let's just say the initial stage or will be from false. So it means that whenever we will start our program, the stop function will start from the stop function. And again we will be copying our while loop for the third time, and this is for our socket. So start it from just removing and just delete this out, place the socket inside, but now this time we will show it by using equal to 0. If it is equals to 0, then it will reset. All right, and also we need these values to be get into this add element build element function. So we'll just go to string, and there we will find out number to decimal string or number to fractional string. So I will connect that in here, and then will be connected to this element, and now it will go to our this table named as socket, change to indicator. So let's just place that in here, connect that, and one thing to do is edit events handled by this case. So I don't want these two events right now, I will remove that, and now I'll set it to socket. So now after doing this, after setting this event structure to socket, now we can just go back and see if it works or not. So if I run my program and I change the value, it will just store with this number. So again, if I change the value, I will see that after 4 seconds the socket power level or any unit level will be changed to 6. So now it is quite easy to extend it to what else you want within this. So like if you just want to add as many more function to make just some simple multiplications or whatsoever you want, and find out the required output of energy, like watts or watts per hour, or as many as you want, you can do it with the simulation by going here and making some multiplications. So I will just leave it in here. But one thing to add in here is just I made the 2D array which showed us the whole data. After we will completing or stopping this, we can get it into this 2D array so that we can save into an Excel file for the furthermore working. So here again I will be using a build array function in here, and let's just extend it. So I will be connecting that in here and then creating a constant in which I'll say um, this will be our, let's just say this is um, this will the first one as create a constant, and the very first one will be our light, and then the second one is like our this data will be our, let's just say, fan, and the fan output will be connected that in here, and the third one is fan and socket, and third data is just connected that in here. Change it to concatenate inputs and just create an indicator. So this will be our indicator in here that I can just place that in here, and let's just say this will be our complete data. All right, so we just don't want a fourth position, so I can remove the fourth column from here. And also let's just say visible items, vertical scroll bar, and let's just go again and remove its index. Complete history, we can just say complete history. So let's just run my program again and change some values and turn on light, turn on, change values, and once it is stopped, each and everything is just stored within this. So you can see time, at which time it is just started, fan and other socket level. So one thing you can do in this to program is you can set values like light, create a local variable like this, and create a fan local variable here, so that whensoever you will close your program, it shall also be giving you the values it should the light turns off and the fan turns off, so that the when you stop the program, all the values at what time the program is just stopped, all the values will be saved into this complete history. So it will be giving it a not function, and then connect it in here as well as with the fan. So yes, you can do this, and create a property node as visible, change it to right, and create a constant of false, but it should be visible when you will press turn on. Oh, so when you will press the stop button, right? So right now it will be not visible. But also one more thing is, we just started from, let's just say, remove this broken wire. We want it to be started from false, Otherwise you can just read in their function. If there's some sensor, we can check if they are turned on or off. So let's just run our program again. This is turned on, and then this is turned on, then this power is changed, and its speed is changed at this at within the second. And when its speed changes this for 6 seconds, the speed is just changed for from 6 to 5. And this turned off after 18 seconds, and socket power level changed after 5. And when I stop, all the history will be generated. So now the next thing is to save this data into an Excel sheet. So for that purpose, you can watch out my this video. The link will be given in the description, as well as it will be appearing on the right side of the screen right now. So that's it. Thank you.